Imagine this. A shadow bigger than a city streaks past Venus, tearing through space at 137,000 miles per hour. 20 kilometers wide, glowing on the side facing the sun like the belly of a blast furnace. And just when you think this is some strange rock or frozen comet, Harvard's Avi Loeb, the same scientist who once dared to say oumuamua might have been an alien light sail, drops another paper that sends shivers down your spine. But this time, he's not talking about sunlight glinting off ice or dust. Loeb says the glow is something far stranger, the calling card of a compact nuclear reactor pushing an interstellar craft across the void. So here we are, standing at the edge of two possibilities. Either we've stumbled onto the first undeniable hint that we're not alone in the universe, or we're looking at the most spectacular cosmic mirage our instruments have ever caught. NASA's Atlas telescope first spotted the object on July 1, 2025. Just hours later, its orbit was confirmed, hyperbolic, screaming in from interstellar space. Here for a blink, gone just as quickly. 3 days after that, the Minor Planet Center gave it a name, 3I/Atlas. Only the third confirmed interstellar visitor after Oumuamua and Borisov, a cosmic stranger just passing through. Now here's the kicker. If all the light we saw was just sunlight bouncing off a solid object, then we'd be staring at something 20 kilometers wide, a colossus, 10 Manhattans stitched together. But when European Southern Observatory teams ran spectral scans, something strange happened. None of the usual comet fingerprints showed up. No water vapor, no carbon monoxide, no shimmering tail. It was acting like a comet that had completely forgotten how to be one. And even weirder, the glow was in the wrong place. Ordinary comets flare on the sun-heated side, their tails sweeping away from the star. But 3I Atlas, its brightest patch was on the leading edge, the side plowing into the solar wind. The light wasn't just reflected, it was smooth across visible and infrared bands, almost unnervingly uniform. Whatever its surface is, it's converting energy into light with nearly 80% efficiency. For context, our best experiments with exotic magnesium silicate coatings, they only managed about 25%. The math is telling us one thing: this shouldn't be happening. Loeb, alongside postdoc Carson Ezel, wasn't about to let this slide. They uploaded a 32-page preprint with a question written in bold. Is 3I Atlas an artificial nuclear-powered probe? Their argument rests on 5 eerie pillars. First, the orbit. Almost everything we've ever tracked in space tilts steeply compared to the plane of our solar system. But 3I Atlas, it's nearly flat, lying in lockstep with the planets. Odds of that happening by random chance? 1 in 500.
Second, the flybys. Trajectory simulations show it skimmed close to Venus, Mars, and even Jupiter, each pass offering a perfect chance to grab a gravity assist, a cosmic free ride. The odds of hitting all 3 alignments by chance? About 0.005%, practically zero. And third, the timing. Its perihelion, its closest brush with the sun, was so precise, so deliberate, that it's hard not to wonder if someone, or something, set it up that way. The story begins with a bit of cosmic irony. When this strange visitor from deep space swung closest to the sun, Earth just happened to be parked on the opposite side of its orbit. A lucky coincidence, at least if you were trying to stay out of view from a planet packed with giant radio dishes constantly scanning the skies. From our perspective, all we could catch was its shimmering forward glow as it drifted away. Astrophysicist Avi Loeb stepped in with a bold idea. What if that glow wasn't natural at all? He crunched the numbers and suggested a compact nuclear reactor could be powering a magneto-hydrodynamic engine, producing exactly the kind of infrared light astronomers had seen. But here's where the mystery deepens. Objects bigger than 10 kilometers shouldn't really exist as free-floating interstellar wanderers, at least not naturally. So, unless someone or something built it that way. Not everyone is buying it, of course. Oxford astrophysicist Chris Lintott went on live BBC and brushed off the alien engineering angle as, well, nonsense. To him, all those probability-based arguments only sparkle after the fact, once you already know the weird outcome. It's like cheering for the winning lottery numbers. You only see the pattern when you're holding the ticket. Meanwhile, Marco Michelli over at ESA reminded everyone of the basics. According to the ATLAS data, faint chemical traces of cyanogen and diatomic carbon, classic comet breath, were detected as it warmed up near the sun, almost like the cosmic snowball was waking from hibernation. To back that up, the Zwicky Transient Facility released a time-lapse showing its brightness pulsing every 7.4 hours, a telltale heartbeat shared by elongated comet nuclei. So the conservative camp drew their line in the sand. It's just another comet, albeit a giant one. We've been cataloging visitors like this for years now. 2017 gave us oumuamua, which sped off with that puzzling acceleration but no visible jets. 2019 brought Borisov, a textbook comet behaving almost too perfectly. And now here we are in 2025 with 3I ATLS, a cosmic riddle that refuses to pick sides. Loeb sees a narrative forming. First a light sail, then a boring comet, and now maybe a nuclear craft. His critics see something far less exciting. Sharper telescopes, more data, and a brain eager to find patterns in the noise. Maybe, just maybe, the truth is hidden somewhere between those extremes, waiting for us to stumble across it. And time is running out. If 3I-APLS really is artificial, humanity has just 6 months before it slingshots past Jupiter and slips out of our reach forever. If it's natural, well, we still get front-row seats to one of the rarest shows in astronomy, a pristine interstellar relic vaporizing under our sun. The James Webb Space Telescope is already booked to stare at it in mid-August, hunting for that telltale heat signature.
And the brand new Vera Rubin Observatory will join the chase, locking down its spin, its surface makeup, maybe even its true origin story. Every observation is a coin toss. Either it chips away at Loeb's bold vision or at the safe, cometary model most astronomers cling to. For now, the universe isn't giving up its secret. So what do you think? Alien craft or dirty snowball? Pause for a moment, imagine what it could mean, and then go ahead, drop your theory in the comments. Is it an alien probe or just a cosmic iceberg? That's the burning question, and you get to decide. Type P for probe or C for comet, and more importantly, tell us why. The best responses will get pinned for everyone to see. Astronomers might chuckle at the idea of a probe, but let's be honest, half of them are already racing to snag every last second of telescope time they can. Curiosity has a way of pushing even the most skeptical minds into action. The cosmos doesn't wait for anyone, and this mystery object isn't slowing down. Scientists have lined up 3 key tests, all to be completed before the year's end, that could settle the debate once and for all. Each one feels like the setup for a cosmic reveal. The first, infrared spectrum analysis. That's where the fingerprints of truth will either whisper natural or shout artificial. Here's the catch. If this thing is a comet, it should shine brightly at 3.4 microns thanks to organic molecules. But if it's a reactor, a sudden spike at 4.8 microns will give it away. Uranium oxide glowing like a tiny furnace in the dark. It's almost cinematic. One number leans toward nature, another hints at technology. And then there's the question of motion. If the object drifts faster or slower by even a few centimeters per second outside what gravity allows, that's not random. That's control. That's intent. Imagine the heart-stopping moment if we catch it nudging itself through space, as if someone somewhere is steering. Radar could deliver the final twist. The Deep Space Network will soon bounce signals off its surface. If the return comes back crisp, sharp, metallic, it could be the whole of something built. If the echo drags and smears, it's just an icy rock, porous and ancient. Either way, Headlines will explode worldwide because the stakes couldn't be higher. But time is the real enemy here. With every passing day, the object drifts further from the sun, growing colder, dimmer, harder to track. By January 2026, it'll pass beyond Jupiter, fading into the black, fainter than distant Pluto. After that, no telescope on Earth or orbiting above it will ever see it again. The chase will be over. That's why this feels so urgent, so electric. The window is closing, maybe forever. Even those who roll their eyes at Avi Loeb's bold claims can't help but root for him in the quiet of their hearts. Because if he's right, if this object is truly an alien craft, everything we thought we knew changes overnight. History would split into two eras, before this discovery and after. Even if it turns out to be nothing more than a natural comet, that in itself would be extraordinary. It would mean we're finally filling in a massive gap in our understanding of how distant planetary systems fling debris across the galaxy like cosmic postcards. And so here we are, caught between two very different futures. In one version of tomorrow, we wake up to headlines that send chills down our spines. NASA confirms alien reactor. The kind of words that would stop conversations mid-sentence, ignite debates at every dinner table, and make even the most skeptical among us wonder what humanity's place in the universe really is. In the other version, the story slips more quietly into history. Astronomers mark down a fresh entry in the growing catalog of interstellar comets, shrug and carry on with the next mystery. No front-page frenzy, no textbooks rewritten overnight. Just another quiet reminder that the universe is stranger than it first appears. But make no mistake, whichever way the story unfolds, it will all come down to the readings gathered in the next 100 nights. That's all the time we have before this visitor slips too far away for our instruments to catch. 100 nights that could tilt the scales toward discovery or disappointment. So keep your eyes wide open and your mind even wider. Keep checking the skies and keep checking in here. We'll bring you updates the second those numbers hit the servers. Until then, hold on to your curiosity, protect your skepticism, and tell me, if you had to choose, what's your heart leaning toward, probe or comet?